It's usually online, but he doesn't want to start with the first one.
Video going. Did any of you look at any of the problems I assigned last time? Did you practice any of that? Do you have any questions on any of them? Sometimes the answer keys are wrong, so that might confuse you. But if you're good with that, I'm really just going to back up to the beginning of 1.4, and I won't spend as much time on significant figures because I already did some of it. But this section, 1.4, measurements, the first thing it does is introduce the metric system. Certainly, you've heard of the metric system, right? Have you worked with it at all in a class somewhere, science class in high school? Okay. I will give you on the test for you to use table 1.2. I'll probably just print this Word file out, but this is just a blown up version of what's there. So maybe you already know these, but you don't have to memorize them. I'll give you that. Just be able to work with it. What you usually do with these, at least as a beginning point, is you need to be able to use this and be able to make conversion factors. For instance, let me just throw an example here. Let's do kilograms to grams. You would start by going to 16.3 kilograms. I always just put this over 1 to make it symmetrical. So what you can get from this is you can write that down, and then you can put an equal sign and put grams, knowing that there's going to be a numerical value there. If you're being asked for grams, you start with your kilogram. But now what you would sketch out next is you would go, I need kilograms on the bottom, grams on the top. All that's missing is some numerical values to go there, and you can calculate it out. So making this, if you're using this chart, what's really missing here is, so you see a billion there, 1,000 there. If there was a 1 here, then it would just mean 1. Another thing that's missing here is you've got grams, you've got liters. When you're in the metric system, I kind of skipped this. It's in the chapter. So in the metric system, length is done in the meter, mass is done in grams, volume in liters. Time in seconds. Volume, they mentioned this later, but volume, that's kind of the definition of a milliliter. But you use length, centimeters, cube, and that's volume. So the volume isn't shown as a definition there, but that's where the definition comes from. So what do I want to do? But assume grams. Notice grams and liter and stuff is not in this. It just has the mixes. But if, say, we were working in grams, and this would be gigagram, megagram, kilogram, decigram, or kilogram, and then right here would be right where there would be a 1. If I could shift this down and put a 1 there, that would just be grams. And then we go to 1/10 of a gram, it's decigram, centigram. So if you need a conversion factor, if you need to go from grams to kilograms, looking at this is saying 1 kilogram is this many grams. So I have a G here. 1,000 grams is 1 kilogram. So if you're going to use that chart, I would say, and then you can calculate it out. being able to make a conversion factor out of this is useful. So you guys have done stuff like this before, right? Used this for conversion factors in a class somewhere? How many have not worked with the metric system? Okay. So not everybody. But what made this simple is I had grams here. This means kilograms. That's in the chart too. The symbol we use, K. So gigagram would be capital G. Gigagrams. Megagrams is capital M. Kilograms. And then next would be grams. And then decigrams, kilograms. This is a capital M, that's a lowercase m. So if you've not worked with this much, you're gonna wanna practice some with this. But if you're using that chart, this number, the 1,000 next to kilo, that 1,000 next to kilo, that's how many grams there are in 1 kilogram. So the 1 is here, and the grams goes here. So 1 kilogram is 1,000 grams. If I calculated this out, I would go, I could do this in a calculator, but the 1,000 just moves this decimal 3 places. All right, 1, 2, 3. So 163,000 grams is 16.3 kilograms. But you'll want to learn how to get your conversion factor off this chart. Or you can do it however you learn to do it, but I'll give you that chart on the test, so learn to use it. All right. These are fairly straightforward when one of these two is grams, the base unit. But notice the twist you get. If I said 16.3 kilograms, and let's do, I sometimes get the micro. What if that's what you're being asked? Kilograms to micrograms. Micrograms is down here, it uses this, I do it pretty good at drawing a micro, but that's a lowercase Greek letter. So, just to do this as a step-by-step way, those of you that have worked with this before, you can do it the way you learned to do it. But if one of them isn't the base unit, first of all, okay, kilograms to grams. So here's kilograms, 1,000. So you would go, I meant that to say 1,000. So 1,000 grams, 1,000 grams is 1 kilogram. And you might use it like that, or you might use it flipped over. One kilograms, grams. So one way or the other. And then you also need to know micrograms, and I would tell you to go, for micrograms, you want this number grams. That many grams is 1 microgram. And you might use it flipped over. Enough zeros there. 1, 2, 3. This is 0. So to come up with a conversion factor to get from kilograms to milligrams, you're going to need kilograms on the bottom. So let me write this, 16.3 kilograms. And the way I'm doing this, you're going to need to go from if you do it that way, these grams cancel each other, the kilograms cancel each other, and you end up in the micrograms that you were aiming for. So now it's two conversion factors. If you have a way that you do this already, that I'm already doing something superfluous for you, but let me finish this out and make my point. Grams to kilograms, so we want this. This one, and now we want micrograms to grams, so 1 microgram, 0.000 grams. I squeezed it in there. Now you can just pile the math together and it will work out and give you the answer. If this is bugging you though, because it's more complicated, you make a point. 2, 3, 4 grams. Let me, I'm going to write the unit weight over here to separate it from the numerical value. All right, if you put that in your calculator and you say 1 divided by this, your calculator is going to give you that as an answer. If you literally put it in your calculator, 1 divided by this, that's not true. If you put in your calculator, what's the answer? Can you tell me? Can you do that in your head? It will actually be 1,000,000. That's what your calculator will be. And notice that's the same thing. Get this out of the way for a second. Micrograms per gram. I could write it that way. But numerically, that's the same thing as 1,000,000 micrograms over 1. This numerical value and this numerical value is the same. You just put something over the 1 and it equals itself. What else can I do? So what I'm telling you is, you could use this conversion factor. But that also equals 1,000,000 micrograms in 1 gram. See what I'm saying? And if I plug this in, I've erased my formula, but whichever one of these I use, I could use this one in my formula and I could use this one in my formula because they're equal to each other. It really just comes down to what your brain wants to do. Usually when I do this, I would say, when I'm down below here in the fractiony ones, I would say 10 decigrams is 1 gram. 100 centigrams is 1 gram, which is different from the way I showed you how to do things. All right, let me finish this one out. I'm going to leave that. Let me rewrite this. I need to get from kilograms to micrograms. So this way my kilograms cancel, my grams cancel, and I end up on the other side of the equal sign, micrograms. I've already said 1,000 grams is 1 kilogram. If I wanted to use this, I would say, is that 1,000,000? Let me write bigger. That many micrograms. So now the kilograms cancel, the grams cancel, we'll end up in micrograms. I should probably start talking about scientific notation. But I want to finish talking about conversion factors. In the same way, I can play games like this, and I could use this. What did I use? So I used this for this term, but I could have used this for this term, and the math is still going to work out the same. So this is kind of like your choice. Does your brain like this, if you're working with that, or does your brain prefer that? Mine does, or the fractioning ones. You see what I'm saying? So however you learn to do this, you can probably just use the method you used. Do you have like a specific method that you learned somewhere? Making metric conversion factors to convert from, say, kilograms to micrograms. Is there a way you learned to do this that you're happy with? Nobody? You're not happy with how you've learned this in the past? We'll practice more of these. I just wanted to introduce it. Let me make a point. Before I go too deeper into this, these are conversion factors going from metric. You're given something in the metric system, and you're converting it to something else in the metric system. So let me sort of categorize what we're doing. Back off this a little bit. You see that that's a metric to metric conversion. All right. Something else I will give you on the test, you don't have to memorize it, is this. You've heard of, sometimes they're called standard units, sometimes they're called English. I see them called US units, United States units. But this is pint, gallon, pounds, ounces, not the metric system. I will give you that on the test, you don't need to memorize it. But the possibilities you have when you're solving a problem is it might be metric to metric. I could do this. Metric to metric. You might be converting between, your book calls these English units, so I'll just say, you might be converting between English and metric. And the only other possibility, converting between English to English. 3 different possibilities. You see that? Okay. What I want to say here is, when you're doing English to English, metric to metric, is different from when you do English to metric, and it's this. Let's look at this first. 1 inch to centimeters. What that's telling you is 1 inch equals, this is, inch is English, inch, foot, mile are all English, not metric. So you got inch and you've got centimeter. So you're doing this, you're converting between English and metric with that conversion factor. Any of these, including this 1 here, that 1, let me point these out. There's a 1 there, a 1 there, a 1 there, a 1, 1, 1, 1, 1. Here we have a bunch of 1s, and we also have a 12, a 3, 500, 5,280, 16, 2,000. Here's my point. When you're doing a metric to metric conversion, no, let me not say that yet. When you're doing an English to metric conversion, what you're seeing here, the way you're going to use this in a math formula is either you're going to go, now you're ready to do some math with it, or you might happen to need to do it this way, depending on what you're trying to get to cancel out. So one of these 2 ways, so when you see this in that chart, go ahead and think like this. You're going to use it either like that or like that. That'll set the math up. Okay. Now let me write down, so this was English to English. No, English to metric. So as an example, English to English, that's this column over here. Let's do, what should we do? Well, 1 foot is 12 inches, that's fine. So there's my example from English to English. And like I said, you're going to use it like that, or you might use it like that. And I guess I should throw in a metric to metric. Metric. And what did we just do? 1,000 grams equals 1 kilogram. You'll use it one way or the other. Okay, 3 examples of those possibilities. And now I want to go back to what we talked about last time, significant figures. Let's say 13.7 inches. I have 13.7 inches. How many centimeters in that is that? And the way you'll set it up is you'll start with the 13.7, 7 inches over 1. You're going to use either this or this. You need inches on bottom and centimeters on top, so that once you do the math, the inches cancel and you end up with some numerical value, centimeters. All right, centimeters to inches. You've got that to work with. I'm going to use this 2.54 on top and 1 on the bottom. All right, and I'll do this too. When I'm working through these, I like to. I'm going to take all the numerical values and put them together like this. 13.7, 2.54, and on the bottom I just have a couple of 1s. And now what I've put here is the numerical values. Now I'm going to put the units over here. Inches, centimeters, and on the bottom inches. I like to put it in 2 categories like this. This is just like the distributive rule for algebra. I could picture this as one long line, and these are all being multiplied by each other. You might have learned to do this where anybody do this, where you put that slash there? Just so you realize it's literally the same. I'm just keeping it like that, but algebraically it's the same thing. Now I can pull out my calculator and do all of this with my calculator. But you remember what I talked about last time? Multiplication, division rule, addition, subtraction rule. This is all multiplication, division. Ultimately, when you put this in your calculator, it's 13.7 times 2.54. I could do divided by 1, divided by 1. I just skipped that. But my calculator is saying and yeah, it comes down to centimeters. So I'm almost to my answer. There's one more thing to consider here, though. Significant figures. There was the multiplication division rule. You can only have as many significant figures as your answer is your smallest number up here. This is 3 significant figures. That's 3 significant figures. So 3 here, 3 here. And here's my point. When you're going English to metric and metric to English, which is this chart, that's 3 significant figures. That's 3. This one has 3. I guess all of these are 3. You count those as 3 significant figures. The side that's not a 1, you count those significant figures. The ones that are a 1, we call those exact, meaning this is 1.00000 all the way out to infinity. That has an infinite number of significant figures. So we're still using the same rule. This has an infinite number of significant figures. This one has 3. This one has 3. So our lowest number of significant figures for our input value was 3. These were infinite. So I'm going to use those as my significant figures. The 9 will round the 7 up. So, and I do this just to point out when you do a calculation, some of your numerical values, you have to consider them as their significant figures to help you decide what to do for your answer. But some of them are considered exact. And it's pretty simple. Let me come down here and finish this thought up here. 9 ones. Inexact means you have to count those significant figures and figure those into your answer. The exact one means you can just ignore them for significant figures. I mean, you might look at this and go, there's a 1 there and it's just 1 digit, so 1 significant figure, 3, 3. Oh, my answer has to be 1 significant figure because the lowest number of significant figures with this 1. What you have to remember is these that just look like integers are actually infinitely exact. There's an infinite number of significant figures. This is just how we write it. If you want to write down the number 1 exact, it's very simple. You just go 1. You don't go 1, 0, 0, 0, 0, 0. I'd stand here an infinitely long amount of time writing zeros. That's how we write an exact 1, like that. So let me put it to you again. That's exact, that's exact, that's exact, that's exact, 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 exact. These numbers are exact. You don't need to consider them for significant figures. When it's English to English, I mean, like it's literally the definition. Someone had a court one day back in 1735 and went, you know what? Split that into fourths and we'll call that cups. And they just decided that'd be the definition. So it's one quart split into fourths exactly is what this means. So all these digits are exact. If I went back to, you get your metric to metric conversions by working with this. But any metric to metric conversions like kilograms to micrograms like I did before, I'll get to that. Let me do this one in the middle. But the point is here, this is exact. That's exact. Let me do it down here. That's exact, and that's exact. So, what have I done? You do it down here. There. This is exact. This is exact. This is inexact. This is inexact. So I'm counting those towards my significant figure. Oh, this was English to metric I'm doing here. So anywhere, I think I'm making this sound more complicated than it is. There's this idea of exact where you don't have to consider their significant figures in your multiplication division rule or your addition subtraction rule. Where you don't have to consider them as any English to English, you don't need to consider those for significant figures. Metric to English, these ones are exact, but that's 3 significant figures. When it's metric to metric, those are exact as well. Exactly 1,000 grams is exactly 1 kilogram. And again, that's by definition. Just like 1 quart is 4 cups. That was just decided as a definition, so it's exact. And then metric to metric, these are exact as well. I don't look at that as 4 significant figures, this is 1. I don't have to consider those for any calculation. The significant figures in these types of problems always come from this arbitrary, I just made up 13.7. That's where all the significant figures are coming from. Or, well, this and the 2.54. I keep skipping back and forth. English to English, all the numerical values that you see in the conversion factor are exact. You don't have to consider them for significant figures. let me do English to English, because I keep skipping back and forth. Let me do this one and just make up a value to work with. I'll just do 13.7 feet. How many inches is that? Well, you're gonna use your feet to inches conversion factor. I'm gonna write 13.7 feet. I'm just gonna put it over one. This one that I put it over that doesn't have units, that's exact as well. Maybe it's obvious, but you don't have to consider that for your significant figure. So now I've gotta get from feet to inches. The numerical values here are 12 inches, 1 foot. And I'll do this just to, if you've got a scientific calculator, this extra step I do to split things out isn't quite as helpful. But I just think it's a process thing that helps my brain. All right. Feet cancels, we end in inches, so that's correct. Now I would put this into my calculator. 13.7 times 12. I could do divided by 1, divided by 1. My calculator says 164.4. I'm getting close to the edge here. So that would be what my calculator gives me. I'm not done yet. I have to look at this and go, what are my significant figures for the answer? That's exact, I don't need to consider those for significant figures. That's exact as well. So this, what looks like two significant figures here, it really isn't, it's infinite significant